Welcome, everyone. Once again, this is Ray Aslin. I'm a trainer for Fortinet. I teach the public cloud security course. This is a Microsoft Azure lab demonstration video for lab number 5. And I recommend, as I've recommended in other videos, if you've seen any of the other videos, you watch the earlier Microsoft Azure lab videos before you attempt looking at this one. So there should be a video with lab number 1 and lab number 2, simple FortiGate deployment. Lab number 3, we deploy a FortiWeb. Lab number 4, we deploy FortiGate clustering protocol, active passive HA. And finally, the final lab in the Microsoft Azure videos, lab number 5, where we deploy an active-active topology. Now, the advantage of an active-active versus an active-passive topology is you're paying full price for all of the FortiGates that are running. Let's take advantage of them. Let's let them flow traffic. Let's let them ease the burden of performance. That is the definitive best case kind of answer for why would I do active-active versus active-passive? Well, the other side of active-active is active-active may have an advantage over failover times because you're relying on a load balancer to do health checks. And if a FortiGate, let's say the FortiOS failed in some way, just stopped responding, the health check could very quickly detect the failure and stop load balancing traffic. We don't have to allow the API to move resources around or make changes to routing table entries. Let's bring up a lab topology. Here we go. This is lab number 5 that we're going to go through together. Now, in our attempt of lab number 5, we're going to do something a little out of the ordinary, but let's pull up a pen here and scroll in a little bit. Let's go pen. Very good. Here, we're going to deploy 2 FortiGates. These are not in an HA configuration in terms of FortiGate clustering protocol. So FortiGate clustering protocol will not be at play here. In that respect, they are standalone FortiGates. So they don't need a dedicated management interface. They don't need a dedicated sync interface. What we're going to use on them is a feature called autoscale. It's a FortiOS feature. It's also a feature, autoscale is also a feature of cloud providers. The autoscale feature in the cloud provider allows for scaling out and adding more VMs and then scaling in and reducing VMs. We talk a lot about that in the last video for AWS. Azure also has that capability, but there's no Azure lab for autoscaling included in this course. This will be the final Azure lab that we go through. This is also a FortiOS feature. Now, the FortiOS feature was built to support autoscale cloud feature. It was built to support scaling out, scaling in VMs. What the feature does is sync up firewall policy and object configuration, policy and object config. That way, if you could imagine, if you were scaling out and adding more FortiGates, you need those FortiGates to have the exact same firewall policies and exact same objects in them. And so there would be a master FortiGate, we'll put an M there, a master FortiGate, and these would automatically sync their config with the master. It's very similar to the config synchronization that happens in clustering. It just doesn't need a dedicated network interface to do it. So we're going to turn on the FortiOS auto scale functionality to keep config in sync between these fellas. And in front of that, we'll have a public load balancer. A public load balancer is a load balancer where the listener is on a public IP address or a DNS name that resolves to a public IP address. Ordinarily, the public load balancer would point to VIPs on these FortiGates. Those VIPs would have firewall policy that would point to some type of internal resource in an internal protected subnet. We're going to have them point to a resource, erase all ink on the drawings, that's actually in this subnet right here. So this trusted subnet, we talked about what transit subnets were a little bit earlier. It could be a transit subnet. Typically, there is an internal load balancer that is also deployed. And this internal load balancer, I wish they had made a change to this diagram. It actually faces the other way. The listener is usually here and it load balances in this direction. And the reason that we use this load balancer is it is the next hop IP in our routing table entries. A little bit earlier, we saw routing table entries that pointed to the active FortiGate in an active-passive cluster. Here we have active-active. Well, we can't have routing table entries that point to both FortiGates at the same time. So we have a routing table entry for these other subnets that point to this internal load balancer, and the internal load balancer can load balance to all of the active FortiGates. So if a VM was plugged into the internal subnet and wanted to go out to the internet, this would direct them to one of the FortiGates and they could go out to the internet. The reply traffic would get source natted. Having a little trouble with my pen there. Let's try that again. The reply traffic would get natted back to that one FortiGate's individual public IP, so it would come back to that FortiGate. Now on inbound traffic, we have inbound traffic that might be going to an application that goes to this public IP address. This is not reply traffic. Perhaps this is someone visiting our website. They go to the public load balancer. The public load balancer load balances this session to a FortiGate. The FortiGate uses its VIP and sends traffic to a VM or possibly to a group of VMs behind their own load balancer. This inbound red traffic that I've shown is typically source natted by this FortiGate so that we make sure the reply traffic always goes back to the same FortiGate. Occasionally, you're going to find in the on-prem world, a lot of times web server admins take a little bit of exception to traffic being source natted before it gets to a web server. And you will find in many topologies in public cloud, both Azure and AWS, traffic has to be source natted. Even if you're not deploying a FortiGate, traffic is typically source natted by the load balancer itself. So one of the adjustments that web server admins have to make when they deploy web servers in the cloud is using cloud-based logging utilities to find the original source IP address. This is just a consequence of using the cloud, the type of topologies that we have in the cloud. A lot of times we can't see the original source IP on the web server. And in this case, the original source IP address that we see will be of the FortiGate on the web server. However, if we look at the FortiGate, we could track the original source IP address from there. So we do have the logs on the FortiGate to see the original source IP coming inbound and load balancing to whatever resource we're sending it to. We're going to use an ARM template to deploy this. I deleted all of my resources earlier. I do want to revisit one thing about deleting resources. I went back into my console and I realized that there was a resource from lab number 2 and number 3 that I never went back and deleted. When I deleted the resource group, it did not include this. So if you've been following along the videos, go into your menu, go to Azure Active Directory, and go to your app registrations. Today is September 11th, and we'll see an app registration that I created a day or two ago. I think I created it on the 10th. So I'm under Azure Active Directory. I go to app registrations. There it is, SX FortiGate Fabric Connector. I created this just a couple of days ago, and I meant to delete it and very clearly did not delete it. So let's go ahead and delete it now. No need to leave that out there. Very good. It's gone, erased from existence. If I look under my app registrations, there's nothing in the display, and I could create more if I needed to. So great. I just wanted to cover that because I forgot to delete it earlier, and I know some of you will follow along and try to do these labs on your own. Just wanted to make sure you knew that you needed to get that deleted as well. Now we're going to use an ARM template to deploy the environment that I just described a moment ago. A bit earlier, we saw that we could go to GitHub and we could find ARM templates there. Something that's a little bit unique about Azure versus AWS is that there are ARM templates embedded in the Azure Marketplace. So you don't always have to leave the Azure portal to use ARM templates. So what I'm going to do is I'm going to say create a resource. And we're going to look for the resource. We're just going to search for FortiGate and see what we find for active-active with a load balancer. And we'll wait. Here we go. So we see single VM with ARM template. I deployed that earlier in lab number 1. We've used that one before. And then right next to that, FortiGate Next Gen Firewall for Azure Load Balancer HA with ARM template. That's what we're going to use here. This will deploy with the auto scale functionality built into FortiOS turned on. So let's go and take a look at that. Let's create. And this is going to feel very similar to lab number 1. It's going to ask us questions about what we want to make, and we're going to answer those questions. Let's call this resource group SX Lab LB for load balancer, SX Lab LB, and I'll try to be a little more careful in Lab 5 about typing correctly. The region is going to be Central US. There it is, Central US. The prefix name, SXFG Lab LB, SXFG Lab LB, looks pretty good. Don't want to do 642, I'm going to go 624 pay-as-you-go licensing. Resource group we've already got, FortiAdmin as a username, a password. This particular template deployment, I like this one. It actually makes me have the password in twice. That way, if I goof it up, I'll get a, there we go. I'll say, hey, this doesn't match. Okay, let's see if we can make it match. Very good. Pretty decent level of confidence now that I correctly typed that in. All right, let's go to the network settings. I'm going to let this deploy a new VNet for me. I deleted my old VNet during the last lab. And it says, oh, I'm creating a new VNet for you. It's the FortiGate protected VNet. It's a 10.0/16 VNet that it's trying to create for me. There'll be a public facing subnet. It'll be called the untrusted subnet 10.00/24, a transit subnet 10.010/24, and internal subnet. And this is where I would typically put my VMs. I'm trying to make this as inexpensive as possible. So I'll turn off accelerated networking. I will change the size of these VMs to F1 SVMs. Now, a little bit earlier, I couldn't use the F1S during HA active passive. During HA active passive, we were using virtual machines that needed 4 NICs because we had to have a public NIC, an internal NIC, a management NIC, and a sync NIC, and we needed 4 NICs, which means I needed a VM that had supported 4 NICs. And generally speaking, if you need more than 2 NICs, the number of CPUs has to be equal to the number of NICs. So generally speaking, if I needed a 4 NIC VM, I need a 4 CPU VM. That's why I had to choose the F4S before, or I'm not sure if it was the S, it was probably just the F4. I'm going to use the F1S. I only need 2 NICs here. I'll have a NIC in the trusted subnet, the public subnet and the transit subnet. Those are the only 2 NICs I'll have. All right, accelerated networking turned off, correct size of the VMs. Next, I will need public IP addresses. The public IP addresses that I need to be standard public IPs. Recall the difference between standard and basic IPs. I believe I mentioned this during Lab 1. We're going through Lab 1. Standard public IPs can be availability zone redundant. So if I'm deploying this into a region with multiple availability zones, and I put one FortiGate in AZ1 or AZA, and I put a second FortiGate in availability zone or AZB or AZ2, B or 2, whatever the second availability zone name is, I want the load balancer to be able to load balance to both availability zones. That means that I need a standard load balancer with a standard public IP. This ARM template wants to deploy a standard load balancer, so I need standard public IPs. So when I go through this, it says first standard public IP. I'll just click create new here. I should get a little side prompt. There we are. And let's call this FortiGate A or something along those lines. So we'll say FG-public-A. And I need to not choose basic. Now note, it will allow me to choose basic in this step. But if I choose basic, the next step is going to give me an error. It's going to say, well, I checked and you did a basic. There's no way for this pop-out to not show you all of the options, unfortunately, which is why the very next step is going to be a verification to make sure you chose standard. I'll choose standard. Very good. Click OK. And this is for FortiGate B. So I'll say create new. Well, I think I'll say create new. Let's try that again. There, create new. FG public. I'll make it exactly like the other one, capital P. Public -B. Standard. This is the IP address that each FortiGate will be able to be used for directly just to reach that one FortiGate. This is going to look a little bit confusing when we get here, but based on how load balancers work with Azure, honestly, it's a little bit confusing. I'll try to step through it slowly, but basically the load balancer will have NAT rules that let me use these individual IPs to simply get to these individual FortiGates. And then there will be another IP address that we can use to load balance back and forth between them. So one IP will simply go to one FortiGate, and then another IP can actually be used to load balance between them. All right, well, let's go to the next step where it verifies. It says, yep, you did a standard SKU. Yes, you did a standard SKU. For fun, let's do something a little different. Oops. Next. Create new. Let's say basic A. Basic. And we'll just choose basic. And I'm just going to do it for A. Let's just see what we, there we go. So if for some reason I didn't do it correctly, it says primary public IP is configured for basic SKU. Please return previous menu. Use standard types to support standard load balancers. Yep, that's true. So we'll say create new. And we'll say FG public A and call it a standard one. Very good. All right, now we can go and it passes the check. We'll go to review and create. We'll get a verification or validation, pardon me, a validation. And it passed validation. That should typically only take 5-10 seconds or so to pass validation. All right, I feel pretty comfortable with that. Let's go ahead and click create. And similar to previous labs, this is going to take a few minutes. So rather than sit here and wait, I'm going to go ahead and pause the video. And frankly, I'm going to get a cup of coffee. It'll probably take some time less than 10 minutes. So something less than 10 minutes from now, I'll unpause and we will continue. Talk to everyone soon. Welcome back. It's been a few minutes since we kicked this off, I think 3 or 4 minutes. And our deployment is complete. So we can move on to the next part of the lab. First, let's just go take a look at the resources that were deployed. So I'll just go into, actually I'll go to the resource group. And we'll go into the load balancer lab group that I created earlier. See what we have. Well, we've got the FortiGate A public IP, the FortiGate B public IP. I see the VNet was deployed. Network security groups, that's just a network security group probably attached to our individual FortiGates. We see the FortiGate A VM. That's a virtual machine. And by the way, if you just get confused, you can always read the type out on the right side. If we go down the list, these are disks that go with the FortiGate. We see we have 2 NICs, and this looks like the NICs for A, and then we have the B virtual machines, the B virtual machine, and the disks and the NICs that go with the B virtual machine. I see there is a public load balancer and an internal load balancer and a routing table. Let's go look at the routing table. Interestingly enough, the routing table entry currently points to a 1.4 as the routes outbound to get to the internet which is within the transit subnet. Let's go back to our resource group list real quick. Let's go to our VNet and there, this is what I wanted to show right here. Plugged into the VNet, 10.0.1.4 is not the FortiGate. This is the first lab where .4 was not a FortiGate. Recall something I might have mentioned earlier in an Azure video. In Azure, as resources are deployed, they are assigned IP addresses in order that they are created in that particular subnet. So the first resource that was created on the trusted subnet was the internal load balancer. So the default gateway doesn't point to a .4 FortiGate IP address. The default gateway points to an internal load balancer, which in turn uses the FortiGates as a group of targets. This way, if a FortiGate goes down or stops responding to the health check of the load balancer can simply direct traffic through the other FortiGates, giving us that active level of high availability. Let's see what else we have here. We have NIC1 on FortiGate A. So I see FG Lab LB-A NIC1. So FortiGate A was created next. It's got the .5 IP. FortiGate B was created after that. It's got the .6 IP. And there we go. We see .4 for FortiGate A on the untrusted subnet or the public side subnet, and .5 on the FortiGate B on the public subnet. Well, that's kind of interesting, right? Now, on the private subnet, the load balancer's listener is .4, and then the FortiGates are .5 and 6. On the public subnet, the FortiGates are 4 and 5. I do not see a load balancer listener for the public load balancer. Well, there you go. It's a public load balancer. Public load balancers listen on public IP addresses. So there's no public load balancer listener on the public subnet. Its listener is external to the VNet. All right, very good. We should be able to go take a look at those load balancers. Let's go take a look at those load balancers. Here we go. These are the icons for load balancers, the internal load balancer. We'll look at that one first. Now, they don't call it a listener on Azure, they call it a front-end IP. And the word listener, probably, when I use the word listener, that probably relates to the first load balancer that I learned years ago. They called it a listener, but it's a front-end IP. There we go, 10.0.1.4. That's the front-end IP of the internal load balancer. Let's go to the other load balancer. It's the other load balancer, public. And let's go look at the front-end IP configuration. Here we have two different IPs. We have a public A IP and a public B IP. This load balancer is used for two purposes. One purpose is to do exactly what we say it does, right? It load balances. So we will have an IP address that can be load balanced to A or B. Now, I also want to take note, neither FortiGate actually owns this IP address. The load balancer owns both of these IP addresses or has both these IP addresses set on it. What we're going to find is that they're going to be inbound NAT rules where one IP address can point to an individual FortiGate. That way we can use one of these for managing FortiGate A, one of these for managing FortiGate B. And then we can have another rule that actually load balances traffic on a particular port. So I'm hoping this will make a little bit more sense as we dig through this a little bit. I do want to make a note of both of these IP addresses. I'll just grab both of these. Both of them, please. Control C, and we'll open up Notepad. Let me show you what I've got here. I don't need that number right there. There we go. I've got the load balancer front end. That's, by the way, that's the name of this, SX, because we created this prefix SXFG Lab LB. I think we made everything have this as the prefix. Public LB, public load balancer, FE, front end. So this is the prefix that we gave it. It's a public load balancer front end. That's what the FE stands for. So this is front end IP address number 1, effectively. And this is front-end IP address number 2, effectively. We'll just hang on to this. This will come in handy shortly. Let's go look at the inbound NAT rules. So there's some inbound NAT rules that say, if you come to this public IP address, .233, let's just hang on, let's go back to the second here. So you got the front end IP address number 1, right? Number 1, this one right here, and we got front end IP address number 2, and I'm just putting this in so really clear, not number 2, thank you. All right, 233 and 236 here. If you come to this 233 IP address and you come on port number 22, we're not load balancing. We're just sending you to FortiGate A. This target is a FortiGate. So that SXFG Lab LBA, that's a FortiGate. That's saying if you go to 233 on port 22, you'll go to FortiGate A. If you go to 233 on port 443, you'll go to FortiGate A. That allows you to use this 233 IP address to manage FortiGate A with either SSH or HTTPS. Conversely, if you go to 236 on port number 22 or port number 443, you'll get sent to FortiGate LBB, and that's again the name of FortiGate B. So these NAT rules are taking these two IP addresses and saying for port 22 and port 443, don't load balance. Let them go to a single FortiGate. If we needed to, we could manage these FortiGates on an alternate port. We could have HTTPS on port 8443 or 10443 or whatever we needed to. We would need to make changes to these built-in NAT rules. These built-in NAT rules are set up to manage on 22 and 443. But we could very much delete the ones that are there and create new ones, and that would be how we could make changes to those rules. So these aren't really load balancing rules, and that's an Azure terminology. NAT rules aren't used for load balancing. NAT rules are for saying on this port and IP combination, go to this one specific host. Let's talk about load balancing. If we're going to load balance, we need a back-end pool of targets. And we do. If we click on back-end pools, we have a pool of targets. There are 2 virtual machines. The 2 virtual machines are SXFG Lab LBA, so that's FortiGate A and FortiGate B. On those respective FortiGates, we're going to load balance onto NIC 0, which is the 10.004 and the 10.005 IP address. So those are my targets for the load balancer. So the ARM template created the public IPs, it created NAT rules so that I could manage the individual FortiGates, and it created a pool with both FortiGates. What it didn't create for me is a load balancing rule. So we need to create a load balancing rule. So I'm going to go to load balancing rules. Oh, well, look at me, I'm a liar. It did create load balancing rules. I thought that you still had to create these manually. I guess the ARM template now also includes load balancing rules. Before we go to load balancing rules, let me look at something I want to show you first. This pool has a name, SXFG Lab LB, because that's the prefix for everything. Public, LB is load balancer, B is backend. So this is the public load balancer backend pool, public LBBE. And there are rules. There are 3 rules in here, and they all use this backend pool. So it looks like it pre-creates one for port 80. Load balance FE1 and FE2 front end port. So you can hit either of the 2 front end IP addresses. So I was just looking through, there's 2 rules here for port 80 that caught my attention. This rule is for port 80, the top one. This rule is for port 80, the bottom one. And each one of them are for probably what I'm going to suspect here are 2 different front end ports. And I suspect that based on the default names, FE1 and FE2. So if you hit front end port 1, front end IP address, 1 on port 80, which I believe was 233, but that's a couple of screens ago. If you hit that first IP address on port 80, you get load balanced to the pool. If you hit the second IP address on port 80, you get load balanced to the pool. And I think we should be able to click on this and verify that I'm correct. Yep, there we go. So the .233 IP address, if you hit it on port 80, you get load balanced to the two FortiGates on port 80. And we'll go back a bit here. And so, right, I pulled that out because you got the front end IP address right here. That's where I pulled that information from. We're getting load balanced to on the back. I think I did this maybe just a couple of weeks ago. And even just a couple of weeks ago, I don't feel like this ARM template was automatically deploying these load balancing rules. Let's go back to the back end. There, load balancing rules, very good. And let's go look at the second one. I'll click on it. The first one is for .233, this one's for .236. And so if you hit the .236 IP address listed there on port 80, it load balances to port 80 on the back end, which relates back to two FortiGates. Well, very good. I know I've got these in here for port 80, but I'm going to set up a Windows server, and the easiest protocol to just use right off the top is RDP. So I'm going to want to RDP into that Windows server and do things with it. So let's just go ahead and add an RDP load balancing rule. So let's go back to the list, to the load balancer configuration, the list of load balancing rule, and let's add a load balancing rule. The name of the rule, we could probably call this anything we wanted, but let's call it RDP because that's going to make the most amount of sense. Let's say add, we'll set the name to RDP, TCP port 3389, backend port 3389. So this is listening on this public IP on 3389, and it's load balancing to port 3389 on our pool members, the two virtual machines being the FortiGate. I'm going to go ahead and click OK. The health probe, I'm just going to take a quick look here. I think I might have to make one change to what I see here. This uses a health probe on TCP port 8008 by default. I'm going to have to make a change to that so that it's health probing on port 3389. In fact, I'm going to stop what I'm doing right now. I'm going to go make the health probe first, because otherwise I'll have to go back and edit this. So let's go back to our load balancer. Click OK. Let's go down to health probes. Very good. Let's add a health probe. We'll call the health probe RDP health probe. TCP port 3389. It's going to check every 5 seconds. Out of time between probe attempts. I'm just curious. It won't let you set it to 1, 2, I bet 3. Looks like 5 seconds is the lowest number that it'll take. There we go. So 5 seconds, unhealthy threshold. Say configured. 2 is certainly it's not going to let me put 1 in there. No, it's not going to let you have one missed health probe. So 2 is the lowest. So this thing should be able to detect a failure within 10 seconds because it's going to health probe every 2 seconds. And if 2 of them in a row fail, it's going to consider the resource failed. Very good. Now we've got that in place. I'm also going to add in a second one. Well, no, I'm not. I was thinking about web, but I'll come back to it. I might go back and create a second one after the fact. So there have been some changes in here to what this does automatically. So I'm thinking about maybe using these HTTP rules for something. But let's go make a load balancing rule for RDP. Add this thing and we'll call it RDP. I called it RDP earlier. I'll call it a load balancing rule. IPv4 should be just fine with me. The 233 front end IP address should be just fine. We'll do TCP port 3389, which balances back to 3389. Where is it going to send it? It's going to send it to the backend pool members, which are my two FortiGates. I will change this probe to use the RDP health probe. So this is why I stopped what I was doing earlier. The health check that it was originally going to do was going to be to port TCP 8008, and I'm not going to have a VIP for that, so it's probably going to fail. So I'm going to change this so that it's pointed to port 3389, which my VIP should allow me to pass health checks on. All right, I don't need to support floating IP or any of these others, so I'm going to go here and click OK. And here we have our list of rules. So now we need a Windows server to sit behind the FortiGates and be the target of our VIP. Before I do that, I just want to take a look at this port 80 rule real quick. Yeah, it uses that health probe. I'm gonna make a HTTP 80 health probe real quick. I'm thinking I might, outside of the scope of the normal lab, I might actually add a web server to that Windows VM. So let's make an HTTP health probe in case I decide to do that later. Health probe. And TCP port 80 looks good. I'll go to the load balancing rules. I'll click on this load balancing rule. This load balancing rule is for IP address .233, and I'll come down here and change it to the HTTP health probe. Very nice, and I should be able to save, it's at the top, save my setting. Give that a moment to finish saving. Actually, while it saves, I don't need to sit here and let that, there it goes, save load balancer rule. So let's go create a resource. Let's go create that Windows server that's gonna sit inside. We'll search for Windows Server. We are sure to get a lot of responses from that search. Okay, well, this is interesting. The Microsoft published Windows Server was not in the first page of results. So let's just change the publisher over here to Microsoft. And that should help us find it a little more easily. There it is, Windows Server. First row, right in the middle. This is the listing that I was looking for. It'll let me pick from various types of images. So I will choose Windows Server. I'll choose the small disk options. I don't need a very large hard disk. I'll choose the Windows Server 2019 data center version, and we will create that. This is just a basic VM deployment, so I'm not going to go through these steps very closely. If you recall, we did this all the way back in lab number 1. We deployed a Windows VM. So I'm just going to go in and say resource group, SX Lab LB, virtual machine name, US central location. Let's go with DS1v2. It's not the least expensive model that I probably could choose, but it'll make my VM a little more responsive because it's got more RAM and power. 40 admin, please. Allow selected ports, and because I think I'm going to add a web server to this later, do port 80. Next, disks. Next, networking. This is going to go into the internal or the trusted subnet. That's what I want right there, the trusted subnet. I could put this in the internal subnet. That's certainly, if I was doing this in production, that's probably what I actually would do. But they have for whatever reason, when they wrote the lab for the course, they have it being deployed as we saw in the lab diagram earlier. So I'll go ahead and follow the actual course material for that, port 80. So I've got port 80 and RDP both allowed on the network security group. I don't need accelerated networking. This is just going to have a little confirmation that I've got boot diagnostics enabled, which I really shouldn't need within the scope of this lab, but I've got it turned on. I'm not going to add any tags. I'm just going to get to the review and create. Unless I have made a mistake somewhere, this should pass a validation check. It does pass a validation check. Let's go ahead and create. Once again, this is a deployment. It's going to take a couple of minutes. However, while we're waiting for it to deploy, we should be able to work on some other things. Let's go back to, actually I don't have to go back to, I jotted these IP addresses down earlier. I was going to say let's go back to our load balancer and get our 2 IPs, but we should be able to, there we go, I've got it in Notepad, we should be able to get the IPs right here. I'm going to go to this IP address on port 443, which should put me on FortiGate A. Proceed. And Control C. I'll use that in a second. Let's log in as Forta admin. And I'll open up a second tab and go to the other IP address. So this is .233, right? And this is .236. So I've got my 2 front-end IPs. My front-end IPs are associated with the load balancer. The load balancer has NAT rules that says if you come to this IP address on port 22 or port 443, don't load balance it, send it to this particular instance. So I've got the A instance right here. We can see the name of it at the top, SXFG Lab LBA. And when it finishes coming up, should be the, there it is, the LBB instance. Very nice. I am going to need, well, before I actually do anything else, before I even configure anything, I want to show you the auto scale functionality that I believe I mentioned earlier. Config, system, auto scale, show. So LBA is the auto scaling master. It has sync interface set to port number 2. So the, relatively speaking, the inside or trusted subnet, that is the side that it's syncing configuration on. There is a pre-shared key that was configured, that was bootstrapped in as part of the ARM template. It's noteworthy that it didn't ask me what to make it, so it made it some random string, I suppose. And I should see a configuration on B that sort of reciprocates this. It should say, I am not the master, or it should be configured to point as A at the master. And we'll just double check that. We'll say config, system, auto scale, show. There it is. It says the master is .5, and I use port 2. And in this case, this system is is it .6? I'm just going to double check myself real quick. Network, interface. Yes, that's right, because that's the same subnet that the internal load balancer sits on. So I am .6, B is .6, and .5 is the other system. Sorry, I'm so accustomed to .4 and 5 being the FortiGates, I had to think about for a second why it would have been pointed at A being .5. But recall, that subnet has an internal load balancer which uses the .4 IP. All right, well, very good. Let's start putting some configuration in to support what we need for our Windows instance. We're going to need a VIP, IPv4, not policy, VIPs, there we are. Create new virtual IP. Let's call this Windows Server VIP, not BIP, but VIP. This should be listening on port number 1. This is the untrusted side interface, right? The 10.0.0 interface. Now for external IP, ordinarily what we would typically do is we would put in that IP, 10.0.0.4. We've practiced that several times. This VIP object needs to be able to be synced to both FortiGates. The other FortiGate is not using .4 on that interface, it's using .5. So if I set this to 0000, when this gets synced, both systems can use it. On the On the mapped IP address, I need this to map to the Windows IP in the 10.01 subnet. And just out of logic, this should be IP address .7. .4 is the load balancer, .5 is a FortiGate, .6 is a FortiGate, .7 should be the Windows. But I have learned not to trust my own instincts. I'm going to go look. So I'm going to go to resource. After the deployment finished, I'm going to go over here and find 10.017. I did make one mistake in my deployment. I can't believe I did this. I assigned this guy a public IP address. That was in no way my intention, was not to assign him a public IP. So we'll see if I can address that issue here in just a second. 10.017, let me just copy this, and we shall go over here and paste this. I could create, ultimately, outside of the scope of the lab, I want to do both port 80 and port 3389. The lab only has me do this with 3389. I thought it'd be kind of interesting to do this with a web server. So what I'm going to do, instead of using the port forwarding technique, I'm going to go this way and say, this is for 2 services, RDP and HTTP. Except I didn't click it. There we go. Now, let's see if I can go back and fix my little goof up here where I assigned this system a public IP address. What I'm going to do is click on the public IP. It should take me to the public IP object. Indeed, here is the public IP object. It's called SX Windows Server IP. What I would like to do is disassociate it. I might need to go do this from the VM or from the NIC, but I thought I would at least take a look. Nope, doesn't look like I can do it here. So I will try doing it from the Windows Server NIC. We'll go to networking. And here is my NIC. I'm going to click on the name of the NIC because the NIC has its own configurational page. I'm going to go to IP configurations. It's right here, IP config 1. And there we go, public IP, disassociate, very good. I don't want Windows to have its own public IP. I want traffic to Windows to flow through my load balancer and my FortiGates so that I'm going through the load balancer IP. This is simply correcting a mistake that I made. If I was paying more attention during the Windows deployment wizard, there was a screen where I could have disabled the assignment of a public IP. So shame on me. Let's go ahead and click save. And I know this is going to take a moment. I'm going to let this occur because after it's done saving this, I'm going to delete that public IP address. Not only do I not want to have it associated with Windows, but I don't want it to have any charges for it while it's just sitting out there hanging out. It's not doing me any good. I have no purpose for it. So what I'm going to do, just to save you guys time so you're not sitting here watching this little status screen, wait to respond, or this screen up here where it says saving network interface, I'm going to pause the video. So I'll be back. It'll probably finish as soon as I pause the video. So I'll be back in just a moment. Yep, that's all I needed to do was pause the video. Once I paused the video, it was done in about 5 or 10 seconds. So very good. Let's get that out of the way there. And we'll go to our list of resources. I'll actually go into this resource group. Put everything in the next lab. This will be a public IP address resource that has Windows in its name, so it should be reasonably easy to identify. We'll say that the resource type is not all, but is a public IP address. Click apply. We'll find the one that says Windows. There it is. And let's try to delete this individual resource. Warning, deleting the selected resource is irreversible. This will permanently delete the, yep, it's going to do exactly what I ask it to do. It's going to delete the resource. There is no returning back from that. You can create a new one, but you're not going to have that one anymore. So I'll say yes, and it shall go away. So I'm sure that'll take another couple of minutes to actually delete, but that's fine. I'm not going to make us wait for the deletion process. I just didn't want that hanging out there. So I wanted to be able to fix my goof up. All right, very good. So let's come back to Mr. FortiGate, and I have this VIP. I created it on FortiGate A, and if we go looking on FortiGate B, policy and objects, and VIPs, well, first of all, I got logged out for inactivity. The VIP should be over there. I would expect that in the time it took me to delete that public IP that I mistakenly made, it certainly, I think, would have synced that up. Policy and objects, VIPs, virtual IPs, and that looks like it's right there. So that part worked, but we still need a firewall policy. So let's create a firewall policy that's based on that inbound VIP. Create new. Windows, RDP, and web policy. If the incoming interface is port number 1 and the outgoing interface is port number 2 and the source is anyone in the world and the destination is the VIP and the services are RDP, or since I'm planning on, or I'm thinking I'm going to do it anyway, HTTP, I'll add HTTP now. Very good. I will source NAT it as it comes in. I'll log all sessions. I think that will be helpful. I'll even do this, log it right away in case there's sometimes reply traffic. I've made a mistake and reply traffic isn't working, and it's nice to get a log entry on the inbound packet. What you'll see is a log entry where there was inbound bytes but no return bytes. And that's usually means, when I do it, it usually means that I've messed up the routes. That's almost always what it means, is that I've made a mistake with the routes. So I feel like that's pretty good. Let's see, with our auto scale functionality in place, I should be able to go to IPv4 policy, and if it hasn't synced yet, it should sync pretty quick. So I'll just refresh and give it a moment to sync up with me. While we're waiting for it to sync up, I'm going to go ahead and get that 233 IP address handy. The reason I'm using the 233 IP, if we go back to our public load balancer, we go back to that public load balancer and we load balancing rules. The 233 IP address is the front end IP number 1. See that guy right there? FE, that's the IP address in question. And that's what I used in my load balancing rule. I said, if somebody comes to port 80 or port 3389 and they're using that front end IP, and if I had any doubts, I could click on this one. Right, the front end IP.233, load balance them. Now I am waiting for my FortiGate to get synced up before I do attempt this, because my load balancer might try to load balance it to that second FortiGate. Say refresh. Well, I'll be honest, I would have expected it to be synced by now. I believe in general my config synchronization is working. Oh, that's probably it right there. In general, my config synchronization is working okay. I've never seen it actually documented, but I have noticed that sometimes I think when something syncs up, I actually get logged off of the non-master. So I suspect that that's it. I'm going to look now and that policy is going to be there because I got logged off, sort of no particular reason. Yep, there it is. So I'm not saying that's officially true, but it sure seems that way to me. It sure seems like that has occurred. All right, well, very good. Let's see if we can RDP into Windows. MSTSC. And we're going to go to that public IP address. front end IP number 1, it ends in .233. I suspect that I'm going to be load balanced over to A. Let's just see. Use a different account, forward to admin, and the password that I set up for this when I was deploying the image. This is the Windows password, that is. And while we are waiting, let's go look at monitor, and not monitor, pardon me, login report, forwarding traffic. I suppose we could have looked at monitor, that would have worked too. Source 168, bunch of different things in here. This gets a little bit tough. As soon as you deploy something like RDP in Azure, there will be somebody on the internet who is scanning your resources. In addition, if we go looking through here, we should also find that the load balancer is doing a health check, and the health check hits the VIP, and the VIP hits the policy, and that'll also come in here. The easier thing to do might be going and looking at the session table, which is under FortiView, all sessions. We'll go look at them on both FortiView, all sessions. 166, that's me. That's me right there. Everything else that I see in here is either going to be and because I have the same IP listed multiple times, it's either going to be the health check or it's going to be somebody on the internet scanning ports on me. And both of those happen pretty often. The health check's constant, right, every 5 seconds. But even being scanned on the internet, I don't have any 166 IP addresses over here. So this is, I'm going to take a guess and say this is all health check traffic. Here's this, although this one is me. So the FortiGate has my original source IP. Let's go ahead and add a more stateless protocol to load balance, like, here we go, like web traffic. I'm going to install IIS. That should be a reasonably useful thing to use in this lab. So I'm going to use PowerShell to do so. This should only take a minute or so, if that even really. We'll say install. Well, a little bit of install. Let's try that again. Windows feature name web server include. There we go. Include include management tools. There we go. Give this a moment. I'm going to go ahead and close Server Manager in the background. While we're doing that, I'm going to get ready for our next test. So the next test would actually be using HTTP to connect to that same front-end IP address. Let's go work on that for a second. Put this over here. There's a little flag. I don't think you guys can see it on your screen. There we go. Make that stick so I can just read that. HTTP colon whack whack 13.89.104.233. Right now it's going to fail. I don't actually, it might pass. Let's say I just got that going there. So let's go ahead and get this guy out of here. Not exit. There we go. And I'm going to need a couple of health checks to pass, but I would expect reasonably fast I should be able to get this to work. There's my 3389 traffic. I'm just refreshing my session tables on both, waiting for 1389, 104, 233. All I'm seeing is my health check traffic. Well, let's just visit Windows very briefly. Let's make sure that this is running locally. So if it's not running locally, it's not going to work at all. I need Internet Explorer up there. It's down at the bottom. That's fine. HTTP:// local host. All right, so it's working locally. Let's just double check a few things, see what might be getting us in any kind of trouble here. I'm going to go and take a quick look at our load balancer configuration, take a quick look at this built-in rule, because I am taking advantage of a built-in rule. Let's click on it and take a look at its details. It says if somebody hits the front end IP address, 8.13.81.4233, backend, so front end port 80, back end port 80, load balance it, use this health probe, which ends TCP port 80. That looks pretty good. Let's go check that health probe real quick. I created that health probe, but you never know. Sometimes I make silly mistakes, and by sometimes I make them all the time. Here we go. So health probe, TCP port 80, every 5 seconds, 2 of them for unhealthy. That looks okay. Let's go have a look at our virtual machines. We have the Windows Server virtual machine. And I want to go look at its networking configuration. I know we looked at its IP address a little bit earlier. Here we are. I just wanted to make sure it had an inbound port rule for port 80. And yeah, 3389, I was pretty sure that one was in there because we have already used that. But I also want to make sure that there was a port 80 rule in there, an HTTP rule, and that's in there as well. So that I feel pretty comfortable that that's not causing us any kind of problems. I'm just going to take a moment, go back to our load balancer, the public load balancer. Health event resolved a few seconds ago. The old value and the new value, HTTP front end 1, front end 2. That's a change history there. 1210 and 47. That was, I wonder if I just started passing the health check. So in my thinking, oh, there's also another problem that I haven't acknowledged is possible that I'll have to take a look at too. So my thinking was that perhaps I installed the web services and the health check was being sent to the FortiGate, and I did see that it was, but it wasn't actually passing the health check until I had the web services enabled on Windows. That's certainly possible. That does happen. If that were true, then all I would really need to do is refresh and it would work now. But I did refreshing and it doesn't look like that's working. So I don't think that that's necessarily what my problem was. I do have one other thing that I think I should go take a look at. This is Windows Windows has a firewall. Every once in a while, the Windows firewall will burn me. So I'm going to go ahead and say administrative tools, Windows Defender, Firewall, Advanced Security. And I'm going to do what we're never supposed to do, just outright turn it off. Rather than look at individual firewall rules, I'm just going to outright turn it off. So it's off public, private, and domain. Apply. Well, I'm still quite curious why this isn't working. This isn't actually part of the lab guide, but I can't think of a reason why this isn't allowing me to do this right now. So give me a couple of minutes. I'm going to pause the video. I'm going to dig into this a little bit, and then I'm going to unpause it and tell you what I found. Because this, in all practicality, should be able to function. I've probably left something out, but I'm going to dig around a little bit, and then I will unpause and let you know what I found. Well, hello everyone. I haven't tested my theory yet, but I think I found out what my problem was, why I wasn't load balancing. So first, a little bit of getting there. I did diag sniffer on each of the FortiGates and sniffed for port 80 traffic just to see if things seemed to be arriving on the FortiGates. And the only thing that I saw arriving appeared to be the health checks coming from the load balancer, and those were arriving just fine. However, that was the only traffic that seemed to be arriving. If I initiated a connection to the front end IP address, that didn't seem to be making a connection on the back end, not in any of the things that I was sniffing for. And I began to think about the fact that this is not a lab that I usually do, and that I had noticed that it had pre-created these HTTP rules for me. And I thought, well, that's really neat. Let's use one of them. And I didn't really think about looking at the HTTP rules that it had created for me very closely. And that's a mistake, right? Just saying that is a mistake. So I went and I looked at these rules, and I deleted a couple of them because I began to realize they all had something in common. And then I realized I wanted to record this, so I stopped deleting the one, and I still have the one that's in play here. So this is the built-in rule that the ARM template created for me. It says front-end IP address number 1 on HTTP, so the .233 IP, front-end port, back-end port, all things that we see here, session persistence by client IP. Look at this part, direct server return floating IP address. If you are not familiar with a floating IP or direct server return and load balancer, the general idea is that when you send a packet to the load balanced target, don't change the layer 3 IP address to that target's IP. Leave it the original listener IP, which isn't going to work for the FortiGate at all. The FortiGate, if the FortiGate gets this with a .233 IP address on it, it's going to go and look at it and go, well, I don't have the .233 IP address. Drop it into the bit bucket. It will go. It's never even going to be evaluated against policy at that point. Does it match the VIP? It's just going to be dropped. So I believe this is probably what my issue is. I'm going to go and delete this rule and create one without it. There are applications that require this. This is something that isn't even unique to public cloud. It's something that I used to see on-prem with load balancers. Now, I've never been an application admin, but I have worked with application folks who have asked for this functionality based on their application needing to support it. And in that case, the servers that ran that application actually had a loopback interface with whatever that front-end IP was, so that when the packet arrived on the interface, it could still work. I'm going to go and delete this load balancing rule, which will, of course, take a moment. And then I will add a new load balancing rule for web. I'm going to call it HTTP RAID rule because I made it. It's mine. 80 and 80. This is what I get for using something built in without examining it very closely. Let's tell it to use the health probe. Feel pretty good about that. Session persistence by client IP. Floating IP disabled, absolutely. Let's go ahead and click OK. Now I'm going to give both of those a moment to complete. While we're doing that, I'm going to show you what else I kind of tinkered around with while I was troubleshooting. I wanted to try to determine if traffic was even arriving. So I actually broke HTTP out into its own policy. So I have a web policy and an RDP policy. And I was seeing byte counts on both, but the byte counts that I was seeing on HTTP was the health probe traffic. That's why I was seeing a byte count on both of those. Let's come back over here. It says it's saved. Moment of truth, I suppose. Let's pull this over here. There we go. Let's refresh a couple times. Make sure it really is working. Yep, it's really working. So there you have it, ladies and gentlemen. Be more careful than I am and never play with a load balancing rule that you didn't make yourself. That's the real moral of the story. Don't play with strangers, don't take candy from strangers, and don't try to use strange load balancing rules that you yourself did not create. So I'm only tickled by that because at the beginning of the lab, I noticed, oh, look, it's created rules for me. It didn't used to do this. It does create rules for you, but as it turns out, the rules are not useful for what I wanted to do. All right, well, while we're doing that, let's go ahead and fail one of our gates. Let's go to virtual machines. There you are. It's processing it right now. That'll be even more fun. Let's go to Forward View, all sessions, Forward View, all sessions. We could pull up the session table in the command line as well, but the amount of session table information we get here should be sufficient. See TCP 80 with a reasonable amount of data. That's probably it. And it's the only thing that was different from the other IPs. See, this is, well, I say that. Now this is the 3389. This is the RDP session. So I've got the RDP session on A, and I have the web session on B, it would seem. Very good. And we'll just refresh this a few more times. I want to keep this session alive. I don't want it out on me. Very good. And since we got web, well, look at that. Let's go back. Say it should go back to B. I think I have session persistence turned on. Yes, multiple TCP 80 sessions there. Let's fail B. So we'll check B. Let's try checking it again. Oh, there it was. Now let's let me stop it. There we go. Stop. Yes. And I'll just keep on refreshing that web page. Ideally, we might have a more interactive web page to work with here. This will be kind of interesting because I just stopped B, but it'll be really neat to see how long it takes before B actually stops responding altogether. Well, I suspect I'm about to get a TCP timeout on B. I think it's about to stop, or if it may have stopped already. Let's go back here, keep refreshing my web page. And if I refresh my list of sessions over here, yeah, I see TCP 80 sessions. So I think it's safe to assume I have session persistence turned on the load balancer by client IP. The fact that it even started load balancing this to A tells me that the load balancer already detected B's failure. I'm just not actually seeing the timeout here real quick because the web application goes a little ways before the GUI web application will actually give me some kind of timeout message. If we go and we looked here, I think we're going to see that we have already successfully stopped, executed stop. It's already stopped. It's not actually responding anymore. So there you go, load balancer giving us that high availability. Well, that is all of Lab5, deploying high availability using the ARM template, putting the load balancer in front of the FortiGates, the FortiGates configured with VIP, using the auto scale functionality to keep policies and objects in sync. I'm going to, once again, delete everything created in the lab, and I'll do that with you all just because I know several folks will have tried to do this on their own, and I want to make sure you see the deletion process. So I will click on the name of the resource group. I'll choose to delete the group. It'll ask me to put in the name of the group when it only comes up here. So I'm going to copy and paste the name of the group in there and choose delete. Didn't have any, but we're going to go double check anyway. Let's go look to see if I have any users or app registrations that were created. We'll go under Azure Active Directory. It's always good to check that if you're doing an ARM template deployment, because remember, ARM templates can also deploy user accounts. Here we go. We'll start with the thing that we should see there is my user account. Yep, that's me, Ray Aslan. Very good. So let's go back to the directory list and go back to app registrations. Oh, a little further, I missed it. There we go, app registrations. And I shouldn't have any at this point. SXHA Lab. This is actually from earlier today. Oh, you know what this is? This was deployed by my template. And this is, let's go back to the other screen. App registrations owned are the ones that I created. All app, this includes the one that was created by, probably by that script earlier. Let's go ahead and delete that. Don't want that hanging out there. So I'll click on it. I just wanted to show that it was there before I deleted it. Definitely go out and get that. There we have it. All right, well, once my group finishes deleting, that should be all of it. It has been my pleasure to do this series of videos for you all. I hope that I get to meet you in class sometime or at an event. Feel free to reach out to me on LinkedIn. I am Ray Aslan, R-A-Y-A-S-L-I-N. It is not a common last name, so I'll be the only Ray Aslan that you're going to find that works at Fortinet. Feel free to reach out and connect with me. Always available for questions. Sometimes it might take me days to get back to you, but you feel free to reach out to LinkedIn, ask me a question, or just say hello. Love hearing that people see the videos and let me know what you thought of it. Thanks a lot. Have a great day.